All right, this is the third part in the 2.6 moments and center of mass. We're just going to do one more example of finding center of mass of a planar lamina. So this is example number 4. Find the center of mass of a semicircle of uniform density 1 with a radius of 3 pi over 4. So we'll go ahead and draw in our circle. I'm going to go ahead and instead of writing 3 pi over 4 a million times, I'm just going to leave it as r, and then at the end we'll go ahead and replace r with 3 pi over 4. So we have a semicircle there, and the equation of the circle there is going to be x squared plus y squared equals r squared. Okay, the upper half of the circle is going to be the positive square root of r squared minus x squared, so the minus would be the lower half. By symmetry, the center, I'm sorry, not the center, but the moment about the y-axis is going to be 0. So you have the same area and density on both sides. So the center of mass, not the center of mass, the moment about the y-axis is going to be 0. Mass is density times area. Okay, so the density here is 1, and the area here, this is a semicircle, so it's going to be pi r squared divided by 2. And so the mass is going to be pi r squared over 2. So the only thing we really have to calculate here is the moment about the x-axis, which is rho over 2, integral from a to b, f of x squared minus g of x squared dx. Okay, so it's going to be rho over 2, integral from negative r to r. Upper function is the square root of r squared minus x squared. The lower function is just 0. Okay, so it's going to give us rho over 2, integral from negative r to r of r squared minus x squared dx. And we'll go ahead and integrate that on the next slide, and we'll finish this problem off. So you have rho over 2, integral from negative r to r of r squared minus x squared dx. So it's going to be rho over 2, r squared x minus x cubed over 3, evaluated from negative r to r. So rho over 2, r squared times r minus r cubed over 3, minus r squared times negative r minus negative r cubed over 3. So rho over 2, r cubed minus r cubed over 3, plus r cubed minus r cubed over 3, which is giving us rho over 2 times 6r cubed over 3 minus 2r cubed over 3. So we have the 2 minuses and the 2 pluses, which is going to be 2r cubed over 3. Now if we want to find the center of mass, x bar, y bar, it's going to be m sub y over m, comma m sub x over m. M sub y was 0, m sub x was, oh wait, that's not m sub x, that's just the whole mass of the system. The mass there was pi r squared over 2. So it's going to be 0 over pi r squared over 2, comma 2r cubed over 3 divided by pi r squared over 2. So that's going to be 0, comma 2r cubed over 3 times 2 over pi r squared. It's going to be 0, and that's going to be 4 over 3 pi times r. Now remember r was 3 pi over 4, and so this works out to a center of mass of 0 and 1, so this looks like it was rigged pretty nicely. Okay, and so that's the center of mass. So if we were to cut out this semicircle of radius 3 pi over 4, cut it out real nicely, plotted that center of mass of 0, 1, and stuck our pencil at 0, 1, then the semicircle should be balanced right there on our pencil tip. Okay, so that is it for this section. We'll go ahead and see you next time.